Yes, so hi, my name is Nico, and today I have a confession to make. I have an unhealthy relationship with robots. It all started 3 years ago when I was a happy front-end developer minding just my own business, and I came across a couple of new browser APIs that would allow me to communicate with hardware devices. But I couldn't make sense out of them, and also I just had no time for another side project, so I skipped this whole part. I wasn't interested in that. But then, 2020, a small virus appeared, and suddenly I had way more free time than expected. And while others were maybe baking bread or stocking toilet paper, I remembered that I have this Raspberry Pi in my drawer. I bought that a couple of years back. Can't even remember why I bought it. It was just there, so in my free time I wanted to play around with that. But it was hard to find any good tutorials because it is already a couple of years old, so I bought the new one, the Raspberry Pi ZRW. And the Raspberry Pi is basically a microcomputer, so it's a fully featured computer. It has a Linux-based operating system, the Raspberry Pi OS, and that allows me to run JavaScript, Node.js files on this little microcomputer. I played around with it. I've built my first prototype of a little toy car, but I suddenly realized that microcomputers are just way too complex for most of my application, of most of the stuff I wanted to do. And also, there's a whole new world right next to that. The world of Arduinos, Raspberry Pi Picos, ESPs, the world of microcontrollers. Now, microcontrollers compared to microcomputers are just way simpler. They are cheaper, they have less memory, they have less processing power. And basically what you do is you would write your C++ program, you can flash it onto the device, and as soon as it has power, it will just run this one program. And that's basically all you want to do, or all I wanted to do with those devices. So from then on, the story took a tragic turn because what seemed to be a nice little adventure turned out to be a pretty deep rabbit hole. And to be honest, I'm still somewhere down there. And fast forward today, I am here to convince as many of you to follow me into this world of unknown devices. I think maybe I lost internet connection. Could that be? Okay. So, but who am I? So, my name is Nico. I am a freelance front-end developer from Bern. I'm also part of the Google Developer Experts program for web technologies, which basically means that I just spend way too much of my free time playing around with all kinds of new browser technologies, web APIs. And today I would like to focus on just two new APIs, and they both try to fill the gap between the browser and peripheral devices around us. And I would like to start with Bluetooth. So Bluetooth is a wireless technology that allows you, or that uses the same frequency as wireless LAN, but it was built to send very small commands over a rather short distance. And with Bluetooth 4.0 and also 5.0, we have a new concept called BLE, which stands for Bluetooth Low Energy. And that's basically a new technology that was focused on IoT devices, so it's very, very energy efficient, as it says in the name, and it also can run over quite a long distance. And also with WebBluetooth, we only talk about BLE because that was the standard that was implemented into browsers. So the way Bluetooth works is mostly like this. You would have one central device, which is the more capable device, and then you would have servers, the peripheral devices. And it's important to mention that you can connect multiple peripheral devices to one client, to one central device, but you can't connect one peripheral device to multiple client devices. So that's, for example, why you can connect your smartwatch and also your headphones to the same smartphone, but you can't connect your headphones to two smartphones at the same time. That's just not how it works, how it's possible. Now, the way, or as part of BLE, the Bluetooth Special Interest Group introduced the generic attribute profile, and that's basically the way how the server exposes data to the client. So first of all, you have this GATT server that provides a list of services, One service is then just a group of characteristics, and now one characteristic identifies the value, and it also defines what operations can be performed on that value. So if you take the battery level, for example, there it makes sense that you can read the value, and you also want to be notified when the value changes, but it doesn't make sense that you can overwrite that value, because you can't just write 100% and then expect the device to be fully charged. That's just not how electronics work. But then again, if you have the flight direction of a drone, it is crucial that you can write to that characteristic. One value is then a very low-level data structure. It's just an array of bytes. And here on the right side, you see a possible implementation of a GATT server on this play bulb sphere. So it's visualized as JSON, and it's very important to mention here that the services and characteristics are not really identified by their names, but by UUIDs. So there is a list of 16-bit UUIDs standardized by the Bluetooth Special Interest Group for most common use cases. Therefore, you know that the 2A19 is always the battery level on each device. Now, if you have custom use cases, like, for example, the light service and the light characteristic on the playbulb sphere, there you can either reach for not yet standardized 16-bit UUIDs or longer 128-bit UUIDs. And there you're free to choose a new UUID, and your client needs to match the UUID. The hard part is now to figure out how those values are structured, because again, an array of bytes is, well, pretty hard to understand for us humans. But the first two are standardized, and those are just the UTF-8 encoded string, basically. The battery service is then just the decimal representation of that one byte, the first byte. And now for the custom services, we need to reach out for the documentation, if there is documentation. There we have documentation, and that's why we know that we have basically 4 LEDs inside that play bulb, and we have 4 values, and each of them represents the intensity of one of those LEDs. That also means that with the mixture of the red, the green, and the blue value, we can basically create any color that we have in the RGB color space. So now that we know about Bluetooth, we can finally have a look at the WebBluetooth API. And the API itself is quite straightforward. First of all, we can request a device, and we can pass a set of filters and also a list of UUIDs of services that we will use later on. And when this code runs, the user will see this prompt. And this prompt will show all the BLE devices around us that match the filter. In that case, we are filtering by name, and therefore we only see the playbulb sphere. The user can now click on this, connect to the device, and on the device you can connect to the server using gatt.connect. Now, to interact with services and characteristics, we'll take the battery service first, so we will need to get the battery service on the service, then the battery characteristic on the service. And to read the value, we can just call characteristic.readValue. Pretty straightforward. And we will then receive a data view, so an array of bytes. In that case, we want to have the first element of that byte array, so as a decimal value, so we can call the getUint8 with index 0, and we will have the battery level in percentages. Now, the battery characteristic also allows the notify operation, so therefore we can add the characteristic value changed event, and that means it will be updated whenever it's updated on the device. It's very important to mention that we need to call characteristic.startNotifications for sake of energy efficiency. Those events are not sent by default, so we need to tell the device, hey, we need those events, we want to have those events. For the light service, it's a bit more complex. First of all, again, we can read the value. In that case, we are interested in the second, the third, and the fourth value, because those are the RGB values. And now, to write a value, we can call the characteristic.writeValue without response. There's also the write value with response, and that depends on how it's implemented on the device. But both functions, they accept a new data view. So basically what we can do is we can replace the old value with a new value, and it will then trigger the change on the device. And that's basically everything we need to know about the WebBluetooth API. Now, to prove that I'm not just making something up, I have my slides are running in the browser. So what I can do is I can just open up the console. I have here now the exact same command you've seen before. So I will just connect to the device and to the characteristic. I can now connect to that. And when I have the characteristic, I can write a new value. So let's try, for example, red, which would be 255, 0, 0, and turns red. So that's my browser that sends the write command to the player sphere and turns the color red. So now that we have the basics, we can finally start building cool stuff. That's the exciting part. So what I did, for example, I created my own slides clicker. And that is basically just a buzzer button, which has a closing contact inside. And I'm using the Arduino Nano RP2040, which is the latest Arduino microcontroller board. And it also has a Bluetooth chip on the board. And what I can do now is I have my C++ program on this board. And what it does is it basically exposes just this one GATT server, one service, one characteristic. The characteristic had 1 byte. And the byte can either be 0 in default state, or it can be 255 when it's clicked. On my slides, I have a key-up event listener. So whenever I press C, I want to connect to the device, connect to the server, characteristic, and so on. And the fun part is now that I can add the characteristic value changed listener. So whenever it changes from 0 to 255, it will show the next slide. Should we try that? So let's turn it on. I press C. Here I see the buzzer. I can connect to that. And now when I click that, it will show the next slide. So then I don't. There's no way back at that point. But then again, I had a very more complex project in mind, and that's speed wheels. Speed wheels, again, is an Arduino Nano RP2040. This time, it's connected to those 2 wheels. And the problem I had is my C++ knowledge is very, very limited. And my ideas were huge. Oh, by the way, my slides will be online right after the talk, so you will have all the links to all the projects on those slides. Again, so I wanted to have the C++ part very, very limited and move all the heavy logic to the client, to JavaScript, where I feel comfortable. So I have basically just this one function. This function accepts 2 values, one for the left wheel, one for the right wheel. And those 2 values can be 0, which would be full speed backward, 100, which would be stop, or 200, full speed forward. And since this value perfectly matches in the range of 1 byte, I basically have this one characteristic with 2 bytes, one for the left wheel and one for the right wheel. And that's already everything I had to do here. So let's have a look at the demo application. Let's turn that on. I can connect to speed wheels. And what we will see next is just arrow keys. Okay. Here we go. Come on. Okay, that's the worst part if you have hardware demos, because hardware is pretty unpredictable. Here we go. So I think the battery is dying, so that's why it's way slower than before. So I can actually control this car using my web application. But having arrow keys is pretty boring, let's be honest. And also the web platform has so many cool things. For example, did you know that you could use machine learning in the browser? There is, for example, TensorFlow. And TensorFlow allows me to analyze a given audio input. And here we go. And in that case, analyze hand gestures inside the video stream. So I can have different gestures that would mean different things. And that works. So we have machine learning in the browser, and it only sends those small commands to update the characteristic on my device. So the next thing I wanted to try is I wanted to work with this pixel matrix. So if you have 16 by 16 pixels, and each pixel has or accepts values for red, green, and blue. So in the end, we do have 16 times 16 times 3, so we have around 670 bytes for one draw of the matrix. The problem is that one BLE characteristic can only store 512 bytes. So what I had to do then, or what I could have done, is I could split my payload into different chunks and to send those chunks. But then again, I would break the whole idea of having this low energy, very fast connection. And also, we do have this completely different technology called USB, the Universal Serial Bus. So the way USB works is, well, let's start way back. So in 1995, we had a whole lot of different serial bus systems for all kinds of devices, and USB tried to create this one standard that would match all the use cases. And since then, we have seen a couple of different adapters. You also have seen a couple of different versions of the specification for faster data transmission, for better charging, and so on and so forth. But in the end, it always has been those 4 cables. So you would have 4 wires, 2 for data inputs, and 1 for the for charging, and 1 as the ground, because you're working with electronics. Now, once I figured that out, this also allowed me to create this one USB cable, where I just placed a switch between the data wires. So that allows me now to charge my phone while plugging it in somewhere at the airport where I'm not sure about what they are doing with those USB plugs. And I know this might sound a little bit paranoid, but in the end, it's very convenient to have this one switch to turn on and off the 2 data wires. The way USB works, the classic way is you would buy a USB device, let's say a printer or whatever. You would then plug it in, you would search for a driver, you would download the driver, install it, you need to grant all kinds of strange permissions. And in the end, you can configure your device, that's what you wanted to do in the first place, and you forget about the driver, and it stays on the system forever. Now, WebUSB tried to create a completely different user flow where you just plug in your device. You will see this little pop-up. You can click on the pop-up that will redirect you to a website there you can configure your device, you can close the site, and you are done. That's all it wanted to do. And you already have the browser as a very, very capable software to do all those configurations. The missing part was WebUSB. So WebUSB looks a lot like WebBluetooth, but there are some strange configurations, and we can forget about all this code, because I created my own little controller class that basically just has those 3 methods. We can connect to a device, we can send data, and we can then listen to incoming data from the device. And that's like 99%, that's all we need to, or all we want to achieve. So back to my matrix. I have the same matrix, but now I've built a little case, and I'm using the Raspberry Pi Pico, which is also a microcontroller, but it's way cheaper than the Arduino Nano, and we don't need Bluetooth on that device right now. So what I do here is my C++ program, it registers itself as a WebUSB capable device, and it exposes a URL. So my operating system knows where to look for the application. And the way I built it then inside the matrix is that I would have this one line of pixels, and it goes as a zigzag through the whole matrix. And now to change the color of one of those pixels, I can just set the R, G, and B values for this one pixel. So in the end, the idea I had, or I came up with, is to have this one big data view where 3 bytes are grouped for 1 pixel. So for example, to draw a heart in rainbow colors, it would be this data view that I need to send to my device. Now let's try that out. So WebUSB is a little bit more difficult than WebBluetooth because you have all the cable stuff. But once you plug that in, we don't see anything. Let's try it again. Yeah, me too. Let's try the other one. Yeah, here we go. We see the prompt. You can click on the prompt. And now the real question is, how much fun can you have with 16 by 16 pixels? I mean, my first cell phone was a Nokia 3310, and it has a couple more pixels, and I was able to spend hours on that device playing games like Snake. So what I did is I wrote Snake inside the browser as a JavaScript application, and it will send the current screen to my device. So that allows me to play Snake. And you should now see it. Yes. Here we go. But the real thing I wanted to do is I wanted to send images to my device. So the next thing I did is I wrote this application that would resize a given image to 16 by 16 pixels. It would crop the image, and it will then take the color values for each pixel, and it will send those values to the device. Let's have a look. Let's try, for example, the Chrome logo. Here we go, beautiful. We also can do things like emojis. And let's take, for example, the FrontConf logo. Here we go, that. Okay, that's bad. But why should we stop there? The next thing I did is I created a way bigger thing, and this one is actually 9 of those matrices. So I have way more pixels, and it works the exact same way. It was a bit hard to know what pixel should be where, but with all those pixels, I tried that in the morning, and I hope this works, and it won't break. So this will work. It will. But I do need to have an external power supply because it's consuming a lot of energy. Here we go. And now the big moment of truth. Yes. It's a similar application. Let's try the Frontend conf logo again. Yeah, it works. So, in the end, to sum it all up, we do have this set of new browser APIs that allows us to communicate with hardware devices. You also have WebNFC, WebSerial, and so on and so forth. And the question I asked myself is, how far can we go with that? And it turned out we can go pretty far, even further than that. So what I did is I created this little web application that analyzes a given input, audio input, and it will then analyze the audio, and it will send commands via Bluetooth and via USB to the devices. And I hope I'm able to create this little performance for you, where I do have my light bulb. I have, this should still work, right? Yes. I've created 2 of those, so. But I think I need to reload first. I have this one here. I have the second one. other side, and that's why I had to have all those cables with me. So again, the light bulb. And also the car. Here we go. So let's try that. Oh. Okay. Thank you. So, I still have 1 minute left for my last slide. So, what's the three key takeaways to take home from this talk? So, first of all, the first question was, how do we communicate with robots? Well, we send bytes either way, via cables or Bluetooth or whatever. The second, we have the web platform is just huge. There's so many amazing APIs on the web platform, and now we are finally able to connect this whole world of the web with the whole world of the hardware devices, which I think is amazing. And the third thing is, especially if you are a front-end developer and you ever want to dip your toes into hardware development, now it is the perfect time. So thank you very much for your attention. The slides are there on that QR code. If there are any questions, I think we do have time for some. Yeah, thank you so much for your attention.
Right. Thank you so much, Nico. I love how you were playing live demo on God mode, and it worked out. Wow, that was the most impressive
Almost
thing.
everything worked.
Awesome. Yeah, we do have time for a couple of questions. So let me see. There's one right here. Nico, have you worked with JavaScript microcontrollers like Espruino or Tessel to get rid of C?
No, I didn't. And that has a reason. The thing is, microcontrollers are very, very limited in terms of memory and all processing power, and there are solutions, but that means you would have a whole JavaScript runtime on your little Arduino microcontroller. And on the other hand, I mean, yes, I am a front-end developer and I love JavaScript, but in the end, I need to have a little bit of an open mind about other programming languages as well. So for me, it was the perfect time to look into different languages. Yeah, that I didn't know before. I mean, I'm not an expert, but I can take some example code and smash it together into this one thing, and it does what I want to do, and I'm fine. Yeah. I will never touch it again. So.
Okay. So how do you power all those LEDs? I mean, this one you power with the cable, but the others?
Yep. The thing is, for the small matrix, it's enough to just power it with the. There's a 5-volt 5-volt pin on the Raspberry Pi Pico, and that's enough for the small one, but for the big one, I need way more amperes, I think. I'm not good at electronics. But it didn't work to just power it from the Pico, so I had to implement this different.
Nice. So you're a hardware hacker too now.
Yeah, I am.
All right. Cool. So there's another question. Can we connect, we can connect to our hardware. How do we figure out how to connect front end to a washing machine? Do they need to support the interfaces?
Well, let's talk for BLE first. BLE is an open standard, and in the end, whenever you have a BLE device, you can just connect to that BLE server, but it's very hard to figure out what UIDs are for which service. Again, the light bulb here has a whole bunch of different characteristics, and not just this one for the light, so I had to figure out which one is for light, how is it structured, and then if you have a washing machine, I'm pretty sure that you will not find a documentation about what's doing this and that, and so that's, yes, let's say, you could do it, but you need to have a little bit of insights how it's implemented on the device then. And for USB, I think you need to have a WebUSB capable device because I needed to write, or I have this C++ library called TinyUSB, and there they have this WebUSB method, and I was just using that. And I'm not sure, I think you need to have this WebUSB capability on the device, so it's not just running on all devices.
Right. It's probably easier to just build a robot that will then like press the buttons on the washing machine.
Yeah.
Awesome.
That's true.
Okay, I think, oh, there's one more question. Do you know of the Johnny 5 library? Have you kept up with
I
these
heard of
APIs?
that, but I never used it, so I can't really say
just
about,
you know of
about
it.
that.
Okay, all right. Will you be around for people to maybe play with your things or like just talk to you about it?
Maybe you won't be able to play with it because they are a bit fragile, but I will be around for any questions for the rest
Thank you
of the
so
day.
much. Great. Everyone give
Thank
it
you.